Problem 8 is similar to problem 7 and gives us the problem where a figure is reflected first along the line x equals -5, and then that image is reflected along the line x equals 1, right as a single transformation. Okay, so let's go ahead and try to make life simple for us ourselves. Let's pick a figure that's the simplest possible figure. Let's pick a point, okay, and maybe I'll pick the origin again, and this is 0, 0. I will call this point A, okay, and this point is then reflected across the line x equals -5. Well, x equals -5 would be where x is -5 on the x-axis, and it would be parallel to the y-axis. So let's go ahead and draw x equals -5 here. So x equals -5, between -4 and -6, and then let's go ahead and reflect this point over x equals -5. Well, A is how many points to the right? It's 5 points to the right. 1, 2, 3, 4, 5. So we've got to go 5 points to the left. 1, 2, 3, 4, 5. This gives us A prime, which is located at -10, 0. And the next part of the problem says that this then has to be reflected across the line x equals 1. So let's go ahead and let's draw the line x equals 1. Let's make that line, again, it's going to be where x is equal to 1, but parallel to the y-axis. So this is going to be the line x equals 1. Okay, it should really go through this point. And now let's go ahead and reflect A prime into A double prime. So how many units to the left of x equals 1 is A prime? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got to go 11 points to the right of this point here, and then that will be the A double prime. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've still got 2 more points to go. I have to draw them in. 10, 11. Okay, that would have been x equals 12 there. So this would be the point. It would be A double prime would be 12, 0. Okay, so again, this was 11 points to the left, and this has to be 11 points to the right of x equals 1, which would be x equals 12. So that would be A double prime, and to go from A to A double prime is the same thing as going from 0, 0 to 12, 0, and that is, we can write that as a transformation of what? Well, we're moving 12 units in the x direction, and we've moved 0 units in the y direction. So we have that the translation along this vector of point A would give us point A double prime. So would this work for another point? Yes, it will, just as we showed before. The translation is going to be the same regardless of what point we pick. So let's go ahead and let's pick a different point just to test that out. Let's pick a point over here. Okay, I'll call this is -4, 3. We'll call this point B. Okay, and let's go ahead and reflect this point over the line x equals -5. And since this point is 1 unit to the right of x equals -5, oops, sure that's correctly labeled there. Since this is 1 point to the right of it, the reflection is going to be 1 point to the left of it. So we're going to have B prime, which is now going to be at -6, 3. Okay, and now to find B double prime, we have to reflect B prime over this line here, x equals 1. So let's go ahead and do that. So we have B double prime, we have x equals 1 here, and let's see how far to the left B double prime is. It's 1, 2, 3, 4, 5, 6, 7 to the left. So in order to reflect it, we have to make it 7 to the right. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7. This is going to be our B double prime. So B double prime is at point 8, comma 3. So we started at B, which was negative 4, comma 3. And we ended up at B prime, which was 8, comma 3. And so what did we do? We didn't change the y value at all, so we still have 0 for the y vector. And for the x vector, we have whatever it takes to go from negative 4 to positive 8, which is positive 12 in the x direction. You can see that was a transformation we came up with when we started with the origin. So it's true also for point B as well, and it will be true for any point whatsoever. The two reflections over these two lines will end up always being a transformation with vector 12, 0.